to the third lecture on Introduction to Hadoop. Myself, Santosh Dante, Assistant Professor in Sri Tulja Bhavani College of Engineering, Tuljapur. In last lecture, we have seen brief history of Hadoop, Hadoop ecosystem, Hadoop command, component of Hadoop, and architecture of HDFS and MapReduce. In this lecture, we are going to learn basic operations to store and access from HDFS via command line. Phase in MapReduce algorithm, YARN architecture and YARN advantages. So we know that in this HDFS environment, you want to store data onto the HDFS from local file system, or sometimes you have to access data from HDFS to the local file system. Here for that, so this Hadoop provides some command usage to get the data from name node to the local or data node, or sometimes you have to transfer data from data node to the name node. So here I shown here a first put command. So what is the purpose of this put command? I have here written a syntax of put command as well as example of put command. So when you want to transfer a data from your local file system to the Hadoop file system, so for that put command is used. So example of this put command, if I want to transfer local file 1 which is residing in my local file system to the HDFS file system, so how I write the command Hadoop fs -put path of local file 1 in destination, the path of destination file, which is file from local here. Copy from local. This act like put command when you want to copy the data from local file system to the HDFS file system. So in that case, copy from local command is fired. Example here I have written, if I want to my test1 file copy from local file system to the destination, so how I write Hadoop fs -copy from local path of test1 file and HDFS destination, the path of that particular new data set directory having the copy test file. So this test1 will copy whatever the content into test1 will be copied to the copy test file. Get command. If sometimes you want to get the data from HDFS file systems to our local file system, so in that case get command is used. How I write the example, Hadoop fs -get test file and on a local destination copy from Hadoop. That means here source test file. So this source test file is from HDFS source and local destination is our copy from local, that means our path of our local destination, local node. Copy to local. Here in this case, sometimes you want to copy data from HDFS to our local file system. Here in this case, I have written the command of this copy to local, Hadoop fs -copy to local new data flare sample. That means this sample files which is of directory new data flare of HDFS source location. That means it is in a name node. and you want to get this file onto your local file or onto your data node. So in that case you have to use this copy to local command. Cat command. Sometimes you want to access the files which is residing in a HDFS file system. In that case you have to use this cat command. Example, $Hadoop fs -cat new data flare sample. That means sample file which is on residing in new data flare directory, and location of new data flare directory which is of HDFS file system. So we get the access of this sample. So for that cat command is used. Move command. If sometimes onto the Hadoop file system you want to just transfer your one file from source location to the another destination location, in that case move command is used. This command is act like cut paste commands. One particular command, one particular file is moved from one location to the another location, so that command will not be there like our copy the files and directory. So the particular files or directory will be removed from that particular locations, and all the contents will be sent to the destination location. Example, Hadoop fs -mv dir1 directory, dir1 directory, that is source directory, and this source directory will be transferred to the another data flare directory. In that case move command is used. Once dir1 command is transferred to the particular from memory locations, so it is already, that means deleted from that locations. The usage will be empty one, and that dir1 file will be get in a data flare directory. cp command. Like mv command, cp command is used for copy the particular file from one location to the another location. So both locations are in a HDFS file system, not our local file system. But from copy from one location to another location onto HDFS file system or onto a name node, this cp command is used. Hadoop fs -cp path of file 1, source file path, and destination side path of destination directory, where that particular file 1 is want to copy. Get merge command. With the help of get merge command you can club many files into a one single file locations and access to the local file system. That means in our examples, in a new data flare there are many files, copy paste, file 1, samples. So all these will be clubbed and will be merged into a merge files, and that merge file is residing in a local file system. That means you get all the merged data from HDFS file system to the local file system. For that get merge command is used. Append to file. With the help of this command you can append many files, local file 1, local file 2, and will be stored onto the one append file. So we are trying to append all these local 1, local 2 present in the local file system into a named as append file in the data flare directory. That means all the data can be clubbed together and that file will be sent to the HDFS file system with the help of this append to file command. What is MapReduce? MapReduce is a software framework and programming model used for processing a huge amount of data. This MapReduce applications can be written by Java, Ruby, Python, C++, various languages you can use. And all this MapReduce having two phases, mainly map, another one is a reduce phase. All these phases get the input into a key value pairs. Here, with the help of this MapReduce algorithms or MapReduce, you can say a technology, you can divide the huge input data into a fixed part, and these parts can be given to the data node for the operation onto that data node, and all these results again integrate and given to the again a particular user. So this is a bigger advantages of Hadoop. With the help of MapReduce technology, many operations can be done parallelly, or MapReduce is having parallel in nature. So here in this example is given a text example having deer, beer, river, car, river, deer, car, beer. All these are words into one text files, and you want to check out the frequency of words or the occurrences of words. So this input is given to the MapReduce. Then what happens? How it works? We will see the phases of MapReduce. Map phases having another two sub phases, you can say, input phase, input split, and mapping. So this whatever the data or huge data will be split into a fixed size, and that splitted data will given to the mapping function. Mapping is the first function of this MapReduce algorithm. This mapping function is used to calculate the occurrences of the given data, that means of the splitted data only. So all this output of this intermediate result or output of this mapping functions will be again passed to the reduced phase. So in reduced phase, shuffling phase will shuffle or will club the all similar output or similar occurrences into one single. So all these result of shuffling will again transfer to the reducing phase to get the aggregate value of this input data or of this result of this algorithm. We will look into this architecture, word count data flow architecture. So here in this input, like I have just tell you that deer, beer, river, car, river, and deer, car, beer. So all these inputs is divided into a fixed size. Here all the one bigger task or bigger input is divided into a many subtasks, you can say, in splitting. All the result of splitting of subunit or subtask is given to the mapping function. That means this mapping function is work on a splitted input, and this mapping function will get the how many occurrences, notify how many occurrences of the word. So here deer, beer, river 111. Second subtask car, river, car is one occurrence as car. That means all these intermediate result of this mapping function again pass to the reduced phase. One thing I want to tell you here, this mapping functions will execute on a single node. Okay, so here the purpose of this single node, that means once it is the output of this mapping function is passed to the reduced phase, this reduced phase will work on a replicated environment. That means once input is given to the mapping function, which is in a residing on a single node. If before getting the output of mapping function, if something happens with the help of that node, then again the same application will be restart one more time. Once all these mapping functions will be passed to the shuffling, that means number of computers, number of node, all these mapping output will be passed to the different node for their operation. So in that case, all these different nodes or different data will be replicated in a reduced phase. The replication data will be getting in reduced phase. In shuffling, we will club all the similar occurrences, and all the result of shuffling phase will be transferred to the reduced phase. In reduced phase, we get beer comes 2 times, car comes 3 times, deer comes 2 times, and river comes 2 times. And whatever the result which is get aggregately into the final output. Component of YARN architecture. YARN is nothing but yet another resource negotiator which is launched by Hadoop 2. So this YARN is used to split or to manage workload, split the activity. YARN allows different data processing engines like graph processing, interactive processing. That means with the help of this YARN architecture, you can split the resources as well as you can control the number of applications which is working on number of cluster. Component of YARN: client, resource manager, having 2 subcomponents: scheduler, application manager, node manager, application master, and container. So in client, this component will just submit the job to this resource manager. Resource manager is used for scheduling all the resources as well as control onto the all applications which is running onto the data node. Resource manager, you can say it is a name node. It will schedule everything or schedule the task which is done by the task manager or data node. Application manager is responsible for accepting the application and negotiating the first container from the resource manager. That means this application manager will communicate to the data node. Also, if application is failure down, so in that case this application manager will restart the application. Node manager. This is a node which having container as well as application manager. This node managers will provide all the resources like memory usage or processor to do the operations given by the task or schedule by the scheduler or resource manager, and notify all the progress of result or application result to the resource manager through the application master. Application master is a single job submitted to a framework. That means there are many applications running onto the cluster environment, and for each application there is one application master. It will notify all the status is going on of the applications. If sometimes want a data from the resource manager, it will be communicated to the resource manager, and application master will use the container launch context to get all the resources by the node manager. Container. It is a collection of physical resources such as the RAM, CPU, cores and disk on a single node. The containers are invoked by container launch CLC, which is record the contents of information. That means containers, you can get the containers, that means all the resources for doing all the tasks. That means task manager will use this container or node resource for doing the operation. This is a YARN architecture. Client submit the applications or request the applications to the resource manager. Resource manager will further communicate to the node manager. Node managers having container and application master. For each application there is a one application master. Containers is nothing but all the resources of that node manager. So here, if sometimes data or environmental data want by the node manager, so we will communicate to the resource manager through application master. So every nodes are communicate to the another node through container and through application master, because application masters is a application manager, you can say, will communicate all these nodes or will let to the all the operations to the container. YARN advantages: scalability. This is such a technology that will provide the way to take any kind of languages as well as all the number of execution engines it provides. So it is used for the scalability of all this Hadoop environment. Compatibility. There are many versions coming on of Hadoop. Right now Hadoop 3 is going on, but it is also compatible to Hadoop 1 and Hadoop 2. So all the applications, existing applications of Hadoop 1 and Hadoop 2 will be easily compatible to the next version. Cluster utilization. With the help of YARN, you can use a cluster, so load balancing is doing well, as well as all the healthy nodes will be come out or will be utilized in a cluster utilization for their next operations. Multi-tenancy. So here this YARN provides or execute different data engines, data access engines for batch, interactive or real time. So all these act on a same data set. So due to this multi-tenancy, improve the enterprise returns on the Hadoop investment. So all the enterprises are happy to invest onto this YARN technology due to it is more open source in nature. Docker containerization. Support for Docker containerization makes it easier you to package and distribute application. That means you have to just focus on your whatever task you want to get by this Hadoop environment, because it is quite easy to do packaging and launching the applications, because time of deployment is very less. Multiple resource types. So you can use multiple resources like memory, CPU and GPU of all this commodity hardware is better. So it is more cost effective or cost expensive way of into the planet to work on a huge data sets. Thank you for watching. So you have to get a fresh new video you have to subscribe my channel so that you notify as soon as possible. Bye bye.